All right, so this is for the complex numbers and rational exponents PFA. So first, here's some notes. I'd recommend taking these notes. The first thing you're going to need to know is the difference between a rational and an irrational number. Okay, so a rational number, and all I'm going to do is give examples here and a quick definition. So rationals can be written as a fraction. And then irrational numbers cannot. Okay, oops. So some examples are for rational, we have 3, root 16, because that is either negative 4 or 4. 0.45. That can be written as 45 over 100, and even simplified. This can be rewritten as 3 over 1 or 6 over 2. There's also one of your examples in a PFA is going to be 10 times, or root 10 times root 40. Well, this is the same thing as the square root of 10 times 40, which is the square root of 400, which is 20, which is a rational number. So if you're not sure, try and solve it, because sometimes that will show you what's a rational number. And then we have like 2/3 and 0.333 repeating, because that is 1/3. Cool. Some examples you'll see of irrational numbers, especially in this PFA and the diagnostic, are going to be square root of 3, square root of 2. These are the most common. Numbers like pi are irrational. That is not necessary for this, but that's the most well-known irrational number. And then we also have things that might be written as like this. Because if you multiply this out, you're going to find that we're left with some root 2's in there, and root 2 is irrational. And then also root 10 over 5. Yes, that's a fraction, but we have a square root number that is irrational in the top of the fraction, so it can't be rewritten as a whole number fraction. Okay? One thing you want to note, because your PFA will ask these questions, is product. It's a result of multiplication. You're going to see this word a lot. So if we take the product of an irrational and rational, the result is going to be irrational. What that means is if I take the square root of 3 and I multiply it to 4, square root of 3 times 4, I get 4 times the square root of 3, and that is irrational. But I took a irrational and rational number to multiply together. So that's the first thing. And the second one is the product of an irrational with an irrational number. And the result here is going to be either irrational or rational. Why? Well, if I take the square root of 3 times the square root of 3, both of those are irrational, but this becomes the square root of 3 times 3, which is 9, and that is either 3 or negative 3, which are rational numbers. But if I take a number like root 3 times root 2, we get the square root of 6, which is irrational. We can't simplify the square root of 6. So those are the rules on rational and irrational numbers. If you need any of those, go ahead and pause the video, take some notes. I'm gonna erase it. The next thing we're gonna go into is radicals. And a radical is like a square root symbol, but it can be more complex than that. So, we're also going to talk about rational exponents. Okay, so the basic rule is if I take the square root symbol, what's here is my base, an exponent is gonna be up there, and this is called my index. So I'll leave that now. I equals index. If there is no index, if it is blank, it is 2. And that's just the normal square root symbol that we know of. E is our exponent, and B is our base. Okay. What's really cool is that this can be rewritten as a rational exponent. So this is a radical, and this is a rational exponent. So we rewrite it as the base to the E over I. So that becomes a fractional exponent. Let's see. So now I'm going to go over some exponent rules, and then we're going to do some practice, which includes questions on your diagnostic and then possibly some in the PFA. So exponent rules. We have something called the product rule, and as I said earlier, that represents multiplication. If you don't already know that, go ahead and write that somewhere because that's really important. You're going to use that word a lot. But it says that if I take an a to the x times an a to the y, exponents are different or the same, but the bases have to be the same. Then we get a to the x plus y. A quotient rule, which means division. So if you need to know that quotient represents division, write that somewhere. Is a to the x divided by a to the y, which is a to the x minus y. So multiplication we add, division we subtract. We can also see this represented as fractions. So a to the x over a to the y is the same thing as a to the x minus y. This is something you're going to use more often than this. You don't often see the division symbol when you get to higher level math. Zero power rule says that anything to the 0 power equals 1. So anything to the 0 power equals 1. And then negative powers. Says that if I have a to the negative x, it is 1 over a to the x. We move to the other side of the fraction bar. Okay, so those are all the rules you need. If you want to write that down somewhere, go ahead and pause the video and do that, but I'm erasing it now. And we're gonna go into practice. Okay, so for practice, we're gonna start with, here we go. There's going to be a lot of example questions, so stick through this video because it will help you answer all the PFA and diagnostic questions. Okay, the first example is going to be, we want to find an expression equivalent to this. So that is negative 3x squared times 4x to the 4th power. The first thing we're going to do is take negative 3 times 4. And then we're also going to take x squared times x to the 4th, which is x times x to the 2 plus 4. Oh, sorry, this should be a negative 2 power. Okay, so this becomes negative 12x to the 2nd power. Okay, in your PFA or diagnostic, I'm not sure where this question came from, keep in mind that it asks for multiple answers, and so you're going to have something that looks like both of these. All right, I'm moving on to the second example. We want to rewrite this as a rational exponent. Well, we know that this can be rewritten as x to the exponent over the index. So x to the 3/5, and that is your answer there. And you can pause this video as many times as you like, of course. I'm just going to try and fly through some of these examples. You can ask me any questions in person. So the next example is going to be the square root of 4x squared y cubed. So we're multiplying a few things inside the radical. So we want to separate square root of 4 times the square root of x squared times the square root of y cubed. Well, the square root of 4 is 2. The square root of x squared is x. And we want to rewrite this as a rational exponent of 3 over 2 because there's an invisible 2 right there. Okay, pause if you need those. I'm going to erase them. All right, the next one is the 3rd root of 27x squared. We want to rewrite this. We have something being multiplied in here, so the 3rd root of 27 times the 3rd root of x squared. Well, we know that this one gets rewritten as x to the 2/3. Now this is kind of weird. In your calculator, it can be tricky to try and use this, but we want to think about what is multiplied by itself 3 times to get to 27. So over here, we're going to do a little factor tree. We know that 27 is 3 times 9, and then 9 is 3 times 3. So our answer here is 3. And this is what you'll end up with. Okay, our next example is 2y to the 0. And all of this we want to simplify. That's all we're doing here. Okay, so the first thing we know is y to the 0 power is 1, right? Because anything to the 0 is 1. So we're just going to take that out. Okay, so 2 times 8, we get 16. And then x to the 3 plus 2, due to the product rule, and we get 16x to the 5th. Again, pause if you need that, because I'm going to go ahead and erase now. Okay, the next example we have is this. So again, we have something to a 0 power, so we know that that is automatically 1. So we are left with 2m squared times negative 9. Negative 9 times 2 is negative 18, and we're left with m squared. Okay. You're going to get a lot of questions like these, so it shouldn't be too horrible yet. Okay, so we have m to the 4th times m to the 7th, same base, so we add the exponents, and we get m to the 11th power. All right. Now we're moving into some of the more tricky ones. I've got about 3 examples of tricky ones. So the first one here is going to be a fraction. So we have x squared, y to the negative 1/3 over x to the 3/2, y to the negative 2/3. Okay, first off, we're dealing with division. We have a fraction bar there, so we want to deal with the quotient rule in the powers, in the exponent rules. And that means that we have x to the 2 minus 3/2, y to the negative 1/3 minus negative 2/3. Because the quotient rule says we're subtracting the exponents. We always want to take the top and then minus the bottom from it. So 2 minus 3/2 is 1/2. And then negative 1/3 minus a negative, so plus 2/3. And we're left with a positive 1/3. If you need help with fractions, I'm happy to help with that because I know that they can be kind of hard to navigate sometimes. Okay, the next one is really lengthy. We have x to the negative 4th, yz cubed. I believe this one is in your diagnostic if you want to find it. Negative 2x, y to the negative 2. And then x cubed, y to the negative 1. So there's a lot of multiplication happening. And so what we want to do is start with our whole numbers. If there is no number, it's just 1. So 1 times negative 2 times 1, and we're left with negative 2. Then we have x to the negative 4th plus x to the 1 plus x to the 3. And then we have y to the 1. If there's no exponent, it is 1. Write that somewhere if you don't know that. And then plus the negative 2 plus our negative 1. And then we have, what'd I do? Sorry. This one should actually be z. So we should have that. Sorry about that. And then we have z to the 3 plus negative 2. Cool. So simplifying that further, we get negative 2x to the negative 4 plus 1 is negative 3 plus 3, we get 0. 1 plus negative 1 is 0. 3 plus negative 2 is 1. So our final answer here, because that's 1, is going to be negative 2z. Keeping in mind that 2 to the 1 power is simplified as just getting rid of the power. Okay, and the final one is just an example of the quotient rule. If we have x to the m, y to the a, x to the n, y to the b, this can be written as x to the m minus n, y to the a minus b. Okay? All right, that is all on exponents and rational exponents. So now we're moving forward to complex numbers. And that's where it kind of gets tricky because I know none of you love how math now is including imaginary numbers. So that's the first thing we're going to cover is an imaginary number. Okay, so if you see an I, that is the square root of negative 1. The reason we get imaginary numbers is because we can't take the square root of a negative number. So we use I to replace that, so we don't ever have to include that in our answer. But what this means is that I squared is negative 1, because if we square that, it cancels our radical symbol. All right, so I'm going to go ahead and just give an example for when this works. If I have the square root of negative 16, I can't say that the answer is 4, right? Because 4 times 4 is positive 16. Negative 4 times negative 4 is positive 16. So there is no way to get a negative number. So now it just becomes the square root of 16 times the square root of negative 1. So now our answer is either positive or negative 4i, because that is the square root of negative 1. So that is what an imaginary number is. Now let's talk about what a complex number is. It says a plus bi, where a and b are real numbers. So I is imaginary, a and b are real. So an example of this is going to be like 3 plus 2i, or 10 minus 5i. Okay, so it's just taking an imaginary number and adding other stuff into it. Right, so all of these new examples are just how to deal with imaginary numbers and complex numbers. So pause if you need to write this. I'm going to erase it. Okay, so the first thing we want to say is, I have examples. So we want to simplify this expression. It says 7 minus 2i plus 3 plus 6i. Okay, so 7, I'm going to rewrite this, 7 plus 3, negative 2i plus 6i. Okay, 7 plus 3 is 10, negative 2i plus 6i is plus 4i, and there is our answer. Okay, here's the next one. We say 6 minus i minus 3 minus 8i. So the first thing I want to do is get rid of the parentheses. So we have 6 minus a 3, and then negative I minus a negative 8i, so it becomes plus. Well, 6 minus 3 is 3, negative I plus 8i is 7i. Okay. And then I have one that's a little more complex here, and it is 5 minus 3i minus 9 minus 4i plus negative 2 plus 11i. Okay, first thing we want to do is get rid of those parentheses. So we have 5 minus 9. And I'm also trying to rewrite it so that I have all my whole numbers next to each other and all my imaginary next to each other, which is what I was doing in these examples. And then I have a plus a negative 2, so minus 2. I have a negative 3i minus a negative 4i, so we add 4i. And then plus a positive 11i. 5 minus 9 is negative 4. Minus 2, we get negative 6. Negative 3i plus 4i, we get I plus 11i, and we're going to have 12i. I did something wrong here. Oh, it's because this should be squared, because you have this question, so keep a watch of this. So 4i squared, that means we can't combine the 4i. We're left with negative 3i plus 11, and we have plus 8i. That's better. And then plus 4i squared, which is 4 times negative 1, because I squared equals negative 1. Now we're left with negative 6 plus 8i minus 4, which is negative 10 plus 8i. I hope that mistake wasn't too confusing. But yeah, there's how to do that one. Go ahead and take a second to review it if you need to. Okay, now we're moving into multiplication. So remember, if it says product of, that means multiplication. So this is what, the fourth? And we're taking the product of 4 plus 3i and 12 minus 2i. Okay, so this is a lot like when we were dealing with quadratics, we're just gonna do the FOIL method. 4 times 12 is 48. Four times negative 2i, and I'm just writing this out so that you guys know what I'm doing here. 3i times 12, oops. So plus 3i times 12. And then our last one is 3i times negative 2i. Okay, 4 times 12, we get 48. 4 times negative 2i gives us negative 8i, so now we have minus 8i. 3i times 12, we get plus 36i. 3i times negative 2i, we get minus 6i squared. So simplifying this down, we get 48 minus 28i minus 6 times the negative 1, because I squared is negative 1. 48 minus 28i, negative 6 times negative 1, we get plus 6. And now we're just combining our last like terms. 48 plus 6 is 54, plus, minus 28i. So that was one of the more complex problems, which is why I chose to do that with you guys. And then I just have one final example. And it is 5 plus 3i times negative 8 plus 2i. So 5 times negative 8, we get negative 40. 5 times 2i, we get plus 10i. 3i times negative 8, we get negative 24i. And then 3i times 2i, and we get plus 6i squared. Simplifying this down, we have negative 40 minus 14i plus 6 times negative 1. I squared is negative 1. Negative 40 minus 14i minus 6. So we're left with negative 46 minus 14i. And that is our final answer. I know this video was kind of lengthy, so thank you for sticking through it, and I hope this helps you on your PFA.